Hi guys, and welcome to another one of my tutorials. In today's tutorial we'll be talking about setting up a autonomous landing mission in INAV. This came in as a request from one of my subscribers. I think it's a fair request to make because I had a video about autonomous landings. I was showing the ins and outs and when it's working and when it's not working and how to react in those situations. So maybe a more detailed setup is quite in order for something like this. So let's go on to the mission control tab where we basically start our landing setup. The first thing that you do is obviously you click on your screen where you want to land. This is my flying field. This is where I fly, and I am usually sitting somewhere here, and then the planes land somewhere there. The remote control ones, obviously. So we want to make sure that it lands there. Now, we select that point, we move it to where we want, and then we go here and edit the point. Now, it's not a waypoint, it's not a point of interest, it's a landing point. And for this landing point, we want to make sure that, first of all, we have the same altitude in the altitude and approach altitude, because this is a waypoint altitude, and the next one is the fixed wing landing altitude. And this is important because you want to make sure that they're the same. So in our case, we want to make sure that this is 50 meters because we're landing. Let's say we start our landing procedure at 50 meters of altitude. You can increase that, but you need to make sure that you increase both of these values. The next thing is the landing altitude itself. This is set to 5 meters. This is where the plane considers to have landed, right? So that's one of the key features in this. And the landing detection is, as far as I understand, it's an algorithm based on vibration, stopping, slowing down, GPS. I don't know, but they've included. I'm not too deep in that, but I'm sure INAV guys did some logical steps in this case. The next thing you need to do is set up your heading. Now, in a situation like this, you might notice, well, actually, our plane might be going over some buildings, houses, whatever. In that case, all you need to do is change the approach direction. So instead of going right, it's going left, or vice versa. Your preferred landing direction can be another angle as well. Let's just take 250, for example. This would be your option number 2. So if you do have other winds that are, present at your airfield, you might want to give a second option for landing because you might have too strong of a crosswind. And in that case, INAV might struggle a little bit in terms of landing nicely and landing on point. It might glide out a little bit. It might land a bit too far away from the waypoint that you've selected. In either case, this is just something to keep in mind because you don't want to have a situation where you didn't take this into account. So the next thing is so this would be saving it, right? So let's just save it to the EEPROM, and we can also save it to the flight controller, although we didn't actually have to save it to the flight controller, and I'll show you in a second why. The most important thing is to actually, after you've set this up, to save it to the EEPROM. The next thing is you go back to the advanced tuning tab, assuming that you've actually gone through this probably at some point, and you have a look at your fixed wing landing settings. Here we have, first of all, the final approach length in centimeters. So this would be 350 meters. This is how far out the plane will go before it actually starts landing. If we want to change that, for example, in my case, I wanted to actually go out, I don't know, let's say like this. I wanted to go out half a kilometer, then it will be 50,000 centimeters. The modifier for pitch to throttle is a value that basically adjusts your throttle and pitch together. I'd leave it as default. If you have some problems with enough speed on landing, it might be a good idea to modify this value, okay? And it would be a good thing to read through the INAV wiki what to do in that situation. I'm not going to go in too deep into that because I don't think it's necessary. Now your initial altitude for the glide phase and initial altitude for the flare phase are the two altitudes that you do have to adjust so that your plane lands in a smooth way. If you have access to a LiDAR, then you can have lower values for these and you can get closer to the ground before actually touching down. However, if you are flying I don't know, something like a Volantex Ranger glider or any kind of a glider, then it might be a good idea to not waste money on a LiDAR and actually just set this value a little bit higher, something like 5 meters, and then set the flare phase to something like 2 meters. Why? Because a glider can handle it. It can fly slower, it can reduce its speed, it will have no issues doing so. Some planes might not be able to achieve this, and this is just something to keep in mind, because if you have something like a T2 Cruiser that you want to land autonomously, one thing that it's going to struggle with is its weight versus how much, you know, like the weight that it carries and the wing loading that is according to that. You don't want your plane to just drop out of the sky. You actually want it to touch down nicely. So in a situation like this, you want to make sure that you're as close as possible to the ground before entering the glide phase, because this is where you lose most of your energy. But on the other hand, if you enter the glide phase too soon, you might actually stall the plane before landing. It's very unlikely to happen. It's very unlikely to happen because, you know, you're just about to touch down anyway. So the chances of you stalling is highly unlikely. But if you have loaded it with some ultra heavy lithium ion packs because you wanted the plane to fly 3 hours, then in that case you want to bring this value down. But in that case you probably also have some cash to spend on a good LiDAR. So definitely worth thinking about, okay? And then the last option that you need to think about is this here, the maximum tailwind. The maximum tailwind basically just tells the flight controller when it arrives at its location. Let's just read it from the improv. So let's say you were flying out here. It came to this waypoint. It starts the landing procedure. It spins a couple of circles and then decides which direction to take to land so that it lands into the wind. In my case, I really don't want the other direction. Like I don't want it at all. I just want it to land either that way or that way. And that's it. So it's either landing towards northwest or it's landing towards southeast. It's just something to keep in mind. I think that this value can be increased for certain aircraft, but the more that you increase it, the more tolerance you give the flight controller when deciding which direction to take. So let's say if you've got a wind that is blowing from the northwest and you decide to land in that direction too, because you've set your speed to 10 kilometers per hour and the wind was like 9, in that case it will still land in this direction, but it might struggle, okay? Because, you know, it will basically overshoot the landing point. So it's just something to keep in mind. And yeah, I think that's pretty much it. I think I've covered everything regarding autonomous landings. If you have any questions, any suggestions, any comments, feel free to drop them in the video below. And yeah, if you want, I'll just drop like a random missions file that you can take, import, whatever. I don't know, leave it in the comments. I'll edit the description if you need a link. But basically that's it regarding the autonomous landing. One interesting thing that I do want to mention is that maybe it's a good idea sometimes to do multiple missions in one go. So the way that you do it is you just add missions with this, and then I don't know, like let's say this is your mission, like really simple stupid mission, and then you can have 3 missions, and then your first mission is, for example, your landing mission. Your second mission is, I don't know, in my case it's like an endurance test mission, and your third mission is whatever. and you can change whichever mission you want because they're all saved to the EEPROM, and you just select the one that you want either during flight or before taking off, however you have configured that. So yeah, that's pretty much it. One thing that I think I forgot to mention was when you save it to EEPROM, don't forget to go into the advanced tuning tab and just make sure that you've got load waypoints on boot selected. That way you don't have to reload the mission via your tablet or whatever you're using in the field. The best way is to just load it to EEPROM and then load waypoints on boot. That way it will pull the information from the EEPROM and put it on the flight controller. And you'll also get the message on screen showing mission or missions loaded. So yeah, that's pretty much it. I hope you enjoyed the video, and I hope this answers most of your questions. If you do have any, of course, drop them in the comments below, and I'll try to get back to most. Cheers. Thanks for watching.